circles, chapter 17. We have solved first and second problem from exercise 17b. We continue from the third problem. Now I'll read the question. So before we solve, please understand the question very carefully. So the question, I will just go back to the original diagram. This was not given, this is not given, this is not given. Okay, wait. Okay, I need to delete this x. Okay, done. This construction is also not there, so I remove that. Then I will redraw that. Okay, so this is the diagram given first in the textbook. So now based on this diagram, the question says that A, B and C, D are two chords which are of equal length, and then point M, which is on AB, is the midpoint of AB, and N is the midpoint of CD. CD I have drawn it somewhere. I'll just rename A and C. A and then C. All right, done. So and N is midpoint of the line CD. This is what is given in the question, and the center of the circle is O. With this datum, he wants you to prove that this one, ABMN is equal to DNM, and angle AMN is equal to angle CNM. So what I will do is, my first step will be construct OM perpendicular to AB. OM perpendicular to AB. Because it is perpendicular, I'll just indicate like this. And then ON perpendicular to CD. Okay, I draw ON which is perpendicular to CD. Done. This is my first step. And because of this, I know that OM is equal to ON. How do I know that? Equal chords are equidistant. We have this property. So instead of writing equal chords or equidistant, here I'm in brackets, I'm writing in brackets here I am writing AB is equal to CD. OM is equal to ON because AB is equal to CD. Okay. Then I will just join M and N. I'll join these two lines, M and N. Now before that, I will show this. OM is equal to ON. Therefore, I'm indicating it like this, and then I will join M and N. Now, if this is angle X, I will call that this is angle X. This angle OMN is X. So this also must be equal to X because OMN is now an isosceles triangle. So that's what I have written here. Consider triangle OMN. Okay. Let OMN is equal to angle ONM is equal to X. Now with this information, next step will be BMO, which is this entire angle. BMO, this entire angle is equal to this part plus this part, angle BMN plus X. So I'm writing that as angle BMO equals BMN plus NMO. Next, BMO is equal to 90 degrees. BMO is equal to 90 degree, and then BMN, I am writing it as it is, and NMO is equal to X. Now if you have this doubt how BMO is 90 degree, we have OMA is 90 degree, therefore BMO, this part must be 90 degree. Therefore I have written BMO equals 90 degree. That's all, as simple as that. Okay. Next, 90 degree. So I'm done with this step. 90 degree is equal to angle BMN plus X. This is just a repetition. I need not write this. Now from this step I can write BMN, angle BMN is equal to 90 minus X. Angle BMN is equal to 90 minus X, and I'm calling this as equation 1. So whatever I did here, I do the same thing on the other side, right hand side. So angle DNO, I'm talking about this entire angle DNO means this entire angle DNO, angle DNO. So this entire angle is equal to this part plus this part. So this part is DNM, and this part is, I'll call it as MNO, which is X. So that's what I have written. So DNO is equal to DNM plus MNO. DNO is 90 degree and this is equal to DNM plus X. I'll send this X on the other side and then I get DNM is equal to 90 minus X. I'm calling this equation 2. Now from 1 and 2, I have, see here, BMN is equal to 90 minus X and DNM is also equal to 90 minus X. Therefore, this and this must be equal. BMN and DNM must be equal. So from 1 and 2, BMN is equal to DNM. So that's the first part. I have proved this. So first part is done. I proved this. I just proved this. Now the second part remaining, AMN is equal to CNM. I need to prove that. For that, what I will do is AMN is equal to, I'll go back to the diagram. AMN, I'm talking about this big angle. This entire thing I'm talking about. AMN is equal to, it consists of two parts, 90 plus X. So that's what I will be writing. So AMN is equal to angle AMO plus OMN. AMN is equal to AMO is 90 and then OMN is equal to X. Done. I'm calling this equation 3. Similarly, I will do the same thing on the other side. CNM consists of two parts, angle CNO plus angle ONM. Angle CNM is equal to CNO is 90 and ONM is X. So I have angle CNM is equal to 90 plus X. I'm calling this equation 4. From equation 3 and 4, this is also equal to 90 plus X and this is also 90 plus X. Therefore, AMN is equal to CNM. AMN is equal to CNM from 3 and 4. So I proved the second part as well. Okay, now next coming to the fourth question. So I have given a lot of construction, everything looks too much over here. I'll delete this and come back to the original diagram and then draw each and every construction. Then it becomes easy for you to understand. Okay, this is the original diagram. Okay. Now with this diagram, we'll first try to understand the question. Please read the question first and only then try to understand this. So the question says, in the following figure, P and Q are the points of intersection of two circles. P and Q are the points of intersection of two circles. Agreed. Okay. And then the center of this circle is O and the other circle is O dash. Fine. APB and CQD are straight lines and they are parallel to OO dash. So APB, the line at the top, this line and this line are straight lines. APB and CQD are straight lines and they are parallel to the line OO dash, and which is indicated by this arrow mark. Therefore, I have put this arrow mark. Okay. Then what else is given in the question? So with this information, I need to prove that OO dash is equal to AB by 2 and AB is equal to CD. These two things I need to prove. I need to prove this and then this. So now my construction will be, construct OJ perpendicular to AP. So OJ perpendicular, and then O dash K perpendicular to PB, O dash K, which is perpendicular to PB. So it's perpendicular. So this also will be 90. That's it. So now I have OO dash KJ. OO dash KJ is a rectangle. I have OO dash KJ is a rectangle. So from this, what I have is JP, which is that it is this point. Or wait, let me choose a different, let me choose orange itself. JP, I'm talking about this step. JP, this part, JP is half of AP. This is a, how do we know property? OJ is perpendicular to AP, so J becomes the midpoint of AP. Therefore, JP is equal to half of AP. Done. I'm calling this as equation 1. Similarly, like that, KP is half of BP. KP is half of BP. So that's, and I'm calling that as result 2. KP is BP by 2, half of BP. I'm calling this result 2. Now equation 1 plus equation 2 gives, equation 1 plus equation 2 gives JP plus KP, JP plus KP is equal to, I'm adding these two, JP plus KP is equal to AP by 2 plus BP by 2. Now what is JP plus KP? JP plus KP gives this entire line, JK. JP plus KP gives this entire line JK, and so it gives this entire line JK. JP plus KP gives this entire line JK. So JK is equal to AP by 2 plus BP by 2. I'll take half common, half of AP plus BP. And what is AP plus BP? AP, I'll use a different color for this, or sorry, this is not A is here, A and P is here, AP plus B is here. So AP plus BP gives the entire line AB. So therefore, half of AP plus BP is equal to half of AB. That's what I have written. Now JK is equal to AB by 2. This is our first, JK is, we have JK is equal to AB by 2. And what is JK? JK is equal to OO dash. Why JK is equal to OO dash? Because of this, OO dash KJ is a rectangle. Therefore, JK is equal to OO dash, and OO dash is equal to AB by 2. I'm calling this a result 3, and this is what we are supposed to prove here. This is what we are supposed to prove. So we are done with the first part. Next, similarly, I will draw one more construction here. From O, I will drop one perpendicular. From O dash, I will drop another perpendicular. Now I have, let us say they are meeting this at M and this at L. O dash M, O dash ML. Sorry, let me change this. This is M and I'll call this L. O dash ML is another rectangle I have. Let me call this L. Okay, done. Now OO dash ML, similarly in rectangle OO dash ML, I will get OO dash is equal to CD by 2. Just like how I proved result 3, I will be able to prove this result 4 also. I need not write the entire thing. I can directly write OO dash is equal to CD by 2. Now from 3 and 4, we have, OO dash is equal to this, OO dash is also equal to this. Therefore, AB by 2 is equal to CD by 2. From 3 and 4, we have AB by 2 is equal to CD by 2. I can cancel this 2 and this 2, and I get AB is equal to CD. That is my second result that I was supposed to prove, and I proved that. That's it. Now let us move to problem 5. Problem 5, the diagram is not like this. I'll change the diagram. Okay, center is O. Okay, M and N are not yet given, so I'll remove that also. Okay, so now this is the diagram given in the textbook. Okay, now I'll read the question. To please read the question carefully, and then I will explain it, and then you will understand better. Two equal chords AB and CD of a circle with center O intersect each other at the point P inside the circle. Prove that this is equal to this and this is equal to this. Okay, two equal chords AB and CD. So AB and CD are equal length chords. That's what it says in the question. Okay, and the center of the circle is O, and they are intersecting at P. This point of intersection, I'll call it as P. Now we need to prove that AP is equal to CP and BP is equal to DP. This is what these two things we are supposed to prove. So now my first construction will be draw OM perpendicular to CD. OM. I'll call this OM, and it should be perpendicular to CD. Because it is perpendicular, I can show like this 90 degree. Okay, this part is done. Next, draw ON perpendicular to AB. ON, and this is perpendicular to AB. Okay, done. Now AB is equal to CD. This is given. AB is equal to CD is given. AB by 2 is equal to CD by 2. I am dividing both the sides by 2. That's all. And AB by 2 gives me what? AB divided by 2 gives me AN. Because N is the midpoint. N is the midpoint of AB. Therefore, AB by 2 gives me AN. AB by 2 gives me AN. Okay, let me use a different color. Let me use green. So, okay, AB by 2 gives me AN. Okay, and similarly, CD by 2 gives me CM. CD by 2 gives me CM. And how do I know that? M is the midpoint. M is the midpoint of CD. Therefore, CD by 2 gives me CM. So this is what is written here, and I'm calling this as equation 1. And the reason I've given here, M is the midpoint of CD and N is midpoint of AB. Next, I will join OP. Okay, done. Now consider triangle ONP and OMP. Consider triangle ONP and OMP. ONP is equal to OMP, and that is equal to 90 degree because of the construction. Next, OP that I just joined is the common side for both the triangles. OP is common. And then ON is equal to OM. ON is equal to OM. Why ON is equal to OM? Simply because equal chords are always equidistant. Therefore, ON is equal to OM. That is done. Now we have shown one right angle, one hypotenuse of both the triangles are same, and then side we have compared by RHS congruency. By RHS congruency, I claim that triangle ONP is congruent to triangle OMP. So therefore NP is equal to MP. How? Using CP CTC, which is corresponding parts of congruent triangles are congruent. Now consider this result 1, AN is equal to CM, and this result 2, NP is equal to MP. 1 minus 2 gives AN minus NP is equal to CM minus MP. So what is an minus np? An minus np is, you have to see the diagram. An minus np gives you ap is equal to cm minus np gives you cp. This is the first part that we are supposed to prove, and the first part is proved, done. Next, coming to the second part. For the second part, what I will do is add 1 and 2. Equation 1 plus equation 2 gives me an plus np is equal to cm plus mp. Please see the diagram. What is an plus np? If you see the diagram, an um, an plus np, 1 minus 2, n hmm. An plus np is equal to cm plus mp. If you add equation 1 and equation 2, you get an plus np is equal to cm plus mp. Now an is also equal to bn. An is also equal to bm. This an is also equal to bn. Why? Because n is the midpoint of AB. Okay, so therefore I'll replace this an with bn plus np is equal to, similarly here cm can be written as dm. Cm can be written as dm because m is the midpoint, plus np. Now what is bn plus np? Bn plus np gives me bp. Bn plus np gives me bp is equal to dm plus mp gives me, see the diagram, you get dp. And this is the other part that we were supposed to prove, done.